A line inclined at pi inclination with the VP and parallel to HP. Right. Now, this line, what is the front view and the top view? Front view is the view obtained here. If you project it downwards, that means towards the VP, right? This will give us front view. This is the front view. This is, I want to use capital letters for the true length, AB. And this is A dash and B dash. What is the top view? The top view is, if you project it downwards, and this is the top view. This is the top view. A, B. Now, if we extend this line, it will cut the vertical plane here, and this is vertical trace. This is vertical trace. If we extend it, it will cut the vertical plane here. This is the vertical trace. This is 3D. How we can look at the same on the 2D plane? For that, extend the top view here up to intersecting point of reference line. After that, draw a perpendicular line to this and extend the front view. Okay, exactly it is passing through the VT. Okay, likewise we can locate the same thing in the drawing sheet. Now I will show the same. Suppose this is the reference line. Okay, and front view and top view. This is the front view, A, B, A dash, B dash, and the top view. This one. This is top view, A, B. Right. To locate the vertical trace, extend it up to intersecting point, draw a perpendicular line to reference line. After that, extend the front view. This point is nothing but vertical trace. Okay? Here, first we consider line parallel to horizontal plane, and we got the vertical trace. And second, we consider line inclined with the VP. That is, inclined with VP gives us vertical trace. Line inclined with HP and parallel to VP gives us horizontal trace. Suppose the line is inclined with both the planes, then it has both horizontal trace and vertical trace. Right. A line of 100 mm length, its midpoint above HP 20 mm and lies in the VP, and it line makes 30 degrees with the horizontal plane and 45 degrees with the vertical plane. Draw the projections and locate HT and VT. Now imagine the line position. See, let it be principal plane, right? And the midpoint M, it is in the vertical plane, and above HP this is 20 mm. The midpoint M is the VP. The fixed point position we need to locate. That is the reason we locate it. After that, 50 mm, half length 50 mm, and this is 50 mm. Okay, let it be A, this is B. B is in first quadrant and A is in third quadrant. Okay, this is the position of respective line, and it makes an angle of 30 degrees, theta equal to 30 degrees, and pi, okay, that means here we can write pi equal to 45 degrees. Okay, right. Now this is the imagination. Now we will draw the respective projections by considering this diagram. A systematic approach gives us very clear clarity about this problem. See, draw the reference line XY. And AB length, that length equal to 100 mm. Midpoint above HP 20 mm. And in the VP. Okay, theta equal to 30 degrees, inclination with HP. Pi equal to 45 degrees. Okay, these are the parameters given in the problem. Now, as usual, first we need to locate the position of fixed point, right? Above HP, therefore, let it be 20 mm. And if it is in the VP, its top view coincides with the reference line. This is M, this is M dash. Okay. Now consider half of the length. We observed that half of the length is in the first quadrant, half of the length is in the second and third quadrants, right? Now first quadrant first we can draw. Okay. With 45 degree, with theta equal 30 degrees, draw a line of length equal to 50 mm only, half of the line. This angle equal to 30 degrees, right? Similarly, in the top view, with 45 degrees, a line of 50 mm you can draw. Let it be A dash, this is A, right? Here, this is not the final position, therefore A1 dash, this is A1. Okay, right. Next one, extend this line for remaining 50 mm. Okay, remaining 50 mm. Extend this line for remaining 50 mm. Okay, that means we got, or we draw the line total 100 mm and we fix the position of midpoint. Now identify what are the moving points. Here this is A1 dash and this is B1 dash. This is A dash A1 and this is B1. Okay, here and it is M is fixed, midpoint is fixed. When we rotate it A, this B also rotates. That means here two fixed moving points, right? Now we need to draw locus lines through the moving points. Here also we draw the locus lines through the moving points, same moving points, right? Okay. Now adapt the procedure. To draw the front view, project the true length from the top view up to a horizontal line which is passing through the fixed point. Here, this is the moving point in the top view. We need to project it up to a fixed horizontal line. Okay, this is the horizontal line. Okay, which is passing through the fixed point in the top front view, right? Right. Now project it, and this fixed point as center, rotate it. Okay, and okay, this is half of the front view, and you can extend it up to the locus line. This is the full AB line front view. Therefore, this is A dash and this is B dash. Okay. Now, for top view. For top view, project the moving point from the front view up to a horizontal line which is passing through the fixed point in the top view, right? By considering this point as center, rotate it. It will cut here. Okay, this is A. Okay, now if you draw a line, this is the required top view, and if you extend it up to locus line, this is B. Okay, this is the required top view, right? Required front view and required top view. Now how we can locate the HT and VT? This line is passing through the vertical plane. That means it pierces the vertical plane. That is nothing but vertical trace. This point itself is vertical trace. Right. Now how we can locate the horizontal trace? To locate the horizontal trace, we need to extend the front view first. Okay, this is the front view up to reference line, and here it is cut. Okay, now draw a perpendicular line. Okay, and extend the top view. This is the top view. Already cut the top view. Therefore, this is the HT, horizontal trace, vertical trace, and horizontal trace. Right? Likewise, different types of problems also we can frame, and we can draw the front and the top views. A straight line AB equal to 100 mm, and this straight line makes an angle of 30 degrees with HP and 60 degrees with VP. End A in the HP and end B in the VP. Draw the projections. Okay, if the problem is like this, see, 60 plus 30, that is equal to 90 degrees. Okay. Now, HP and VP both are perpendicular to each other. And if the line, it is 60 plus 30 equal 90, see, this will be like this. The line will be like this. Right? If it is like this, front and top views, if you club, it will be a straight line. It will obtain like this, right? Right. Now, how we can draw the front and top views? See, this is XY reference line, and strictly speaking, this problem we need to draw from the side view. Okay? I want to cover from this side view. If you see the side view, see, with HP 30, with VP 60, right? The line will be like this. This this is 60 and this is 30. And this total line length, let it be A double dash, this is B double dash. B is in HP, A is in VP, right? Now, by considering a line with 45 degrees angle, project it downwards and project here, right? Project here, right? Now, if you draw a line like this is the A dash and this is the B dash, which gives us front view, right? Now, in the top view, see, this is the line we project here and here. This is A and this is B. Okay? Likewise, we need to draw the respective line, and it will be a vertical line. Okay, if theta plus phi equal to 90 degrees. This is the simple one or simple procedure to draw the line inclined to both the planes when the orientation is like this, right?